Here we're going to look at something called vector journeys. These are sometimes called vector pathways. You need to remember vectors are all really about the start and end points of a journey. What happens between our two endpoints can be expressed in a couple of different ways. A nice wee example is this wee map here, and that these three roads, blue, red and green, they've got the same beginning and end point. Now the blue road takes us all the way around here, the green road takes us all the way around here, and the red road is a more direct route. In terms of vectors, these three journeys are the same because they've got the same end point and the same beginning point, and we're going from one to the other. So in terms of vectors, these are all the same. And we can use this to describe different pathways on diagrams. So I want to express a number of vectors here in terms of A and B. Now basically what this means is I can go along any line on this diagram so long as it is represented by A or by B. So it basically means this line here is a no-go. I'm not allowed to use this line here because it's not represented by A, nor is it represented by B. We don't know what letter we can use to represent it. So, first one, if I wanted to represent the vector PQ, well that's a nice easy one, because going from P to Q is going along this vector B and is going in that direction of travel. So PQ can be represented by the vector B. Next one asks us, what about QP? How can we describe that journey? Well, going from Q to P, we're going along vector B, but we're going against the direction of travel. So what we're doing here is we are going backwards through B, and we represent that with a negative B. So we're travelling along the vector B, but we're going in the opposite direction from what it's pointing in. PR. So the vector PR, I'm asking myself, how can I get from here to here? Well, this pathway is the vector A. However, I'm going against the direction of travel. So I'm going backwards through A. I'm going negative A. D. The vector RQ. So I am being asked, how can I get from R to Q? Now, the vector we're looking at is this straight line here, going from R to Q. However, this has not been described in terms of A and B. So we're looking for an alternate route. It's a case of we are trying to find a blue or a green route on this map here. So to get from R to Q, only using A and B, I'm going to have to go along A, then I'm going to have to go along B. So my journey can be described as the vector A plus the vector B. Because remember, when we've got vectors added together like this, sort of head to tail, there, they're being added. So to get from R to Q, I've got to go down here and then down there. QR. Well, to get to Q to R, again, this is out of order. I can't use this line here. I have got to go backwards through B, and then backwards through A. So I have got negative B, negative A. Now, the connection between these two vectors, RQ and QR, are the same vector, just this is in the reverse order from that. So if we look here, I could have done this. I could have said QR is the negative of RQ. It's the same vector but backwards. So that means it's going to be the negative of A plus B. And remember, this really means negative 1 times whatever is inside the brackets. So I'd have the negative of A, the negative of B. Now the order we add things in, because remember, subtracting and adding are essentially the same thing. The order these have been added in doesn't matter. If I go back to my diagram here and sketch this on, negative A, negative B. Well, negative A is going to be roughly like that. That would be negative A. And then negative B is going to be roughly that. So sometimes our pathways don't even need to be on the diagrams to take us from one step to the other. Negative B, negative A, though, this version here, that's probably the more sensible one, just tracing it along.
Right, here's another problem involving some parallelograms. I've got OACB, so OACB, and BCED, so these two parallelograms are congruent parallelograms. Congruent means exactly the same shape and size. Parallelograms is going to come in useful in terms of vectors. M is the midpoint of OC. OA has been called 2A, and OB has been called B. Find the following in terms of A and B: OC, OM, and DM. The fact these are parallelograms is super useful because this side and this side are exactly the same length and are pointing in the same direction, i.e. they're parallel. So it means this side here is represented by the vector B, i.e. the instructions to get from here to here are the same as for getting from here to here. Because the two parallelograms are congruent, it means going from B to D can also be represented by my vector B, and going from C to E can also be represented by that vector B. The same can be said for these two sides here. Because this side is parallel and the same length to this side, I can say this guy here can be represented by 2A, and the same holds true for this guy over here. So we can pretty easily get around this parallelogram using the letters A and B. Now the problem is, to get from O to C, we're crossing diagonally. So it's impossible to use this line here because, well, it's not labelled with A, small a, or small b. So what we've got to do is we've got to take the long way about it. So to get from O to C, there's two ways I can do this. I could go from O along to B, and then from B up to C. So that would be small b, followed by 2A. My alternative way of doing that is to go up this way, which would be 2A, and then go along here, which would be B. Now, the order we add things in doesn't matter, so both of these examples, both of these answers are the same. Now, if I wanted to figure out OM, again, this is where all this text comes in useful. M is the midpoint of OC, so this is halfway along that line there. So OM is half of the vector OC. Now, we already know what OC is. OC can be written as this. So I could say OM is going to be a half of B plus 2A. So that's going to be a half of B plus a half of 2A, which will give me a single A. Again, if we just sort of roughly try and sketch on what that looks like, O to M, a half of B, and well, if all of this is 2A's, a single A is going to be roughly that. So that's what that would look like. And that would take me from O to M. Now, the last one, DM. So to get from D to M. Some folks find it useful, so you might want to print out the sheet if you've got access to a printer, or if you're able to use a tablet like I'm doing here. Some folks find it useful to actually highlight the path. So we can't go straight from D to M because, well, we've got no information about that. So we won't have to take a sort of long way around. And this question's been structured deliberately, and that, well, we've just figured out that vector there. So that's actually the hard bit done. So all that I've really got to do is I've got to get from point D back to point O, and then I can use this vector here. So what I've got to do is I've got to break this down. I've gone backwards through B and backwards through B. So I've went negative B, or I suppose I could even write that as negative 2B. I've went backwards through two of my B's. And then I need to do this. I need to go along OM. Now, I know that the vector OM is this here, because I figured it out previously. So I've got negative 2B plus a half B plus A, because this is the vector OM. Now, I need to tidy this up. I have got negative 2 plus a half. Well, that is going to give me negative 1.5 lots of B plus a single A. Now, here's a third and final example. This one coming from an old SQ exam paper. In the diagram below, RQ and PQ represent the vectors C and D respectively. And that's all on the diagram there. Part A, express PR in terms of C to D. So how do I get from P to R? So I've been asked to find this guy here. PR, well, it's going to require me to go forwards through D. So that'll be D, and then backwards through C, so the reverse of C. So I would write that as negative C. And that's that done for 1 mark. Now, the second part here is where the diagram gets a little bit more complicated. The line QP is extended to T. So that's telling me this is all one big straight line. Then I've been told TP equals QP. And I've been told V is the midpoint of PR. Express TV in terms of C and D. Right, this is the vector I'm trying to find here. So how do I get from T to V? Now, I have got absolutely no information about that, so I don't know anything about it in terms of D and C. However, I've been told TP is equal to PQ, and because this is the same straight line, it means this guy here can be represented by the vector D. So to get from T to P, I've got the vector D. Now, all I need to do is get from P down to V. So I can start communicating this. The vector TV is going to be T to P plus P to V. And I know T to P is the same as the vector V. Now, PV, I don't have any information about PV. Well, other than this. This is the halfway point along this line here. And part A had us figuring out this vector from P to R. So PV is half of the vector PR, which means it's going to be half of my answer from part A. So it's going to be a half of D minus C. So I need to expand those brackets. So I've got a half D minus a half C. And then tidy it up. I've got D plus half D. I'll just write that as 1.5 D minus a half C. And that is a slightly more complicated one for 2 marks. Now, questions you've got here. Again, if you have access to a printer, you might want to print it off so you can be drawing on or highlighting various points here. 2 questions at the top of the sheet. We've got a parallelogram. So this idea of these sides are parallel and equal length. So you're going to have repeated vectors here. Your diagonals are going to cross and bisect. So M for midpoint really. So it's halfway along these 2 lines. We've got a trapezium. We've been told that these sides are parallel. We've been told that HG is 4 times this in length. So 4 of these vectors will make up that. You've then also got some information about a pair of midpoints. Again, tracing your way along this is going to be useful for figuring out some of these later ones. 2 more. Again, this hexagon one, you've got a hexagon where all of these lines going from bottom left to top right, the ones I'm tracing out here, these are all the same. These ones, the horizontal ones, these are all the same. Now be careful, I'm going to highlight here, just in red, these ones, we don't know anything about them. You might be tempted to say that that's negative S, but it's not. Those red ones are out of bounds. You cannot use those. So this question is going to be sticking to those non-highlighted lines. Another trapezium in that 4th question. Again, parallel sides. You've got some information about your lengths. Again, tracing out on paper could be quite a useful way. So using highlighters is a nice way to try and crack those. There's also this question added on just to give you a little bit more practice at working with midpoints. And this one's got 3 different vectors. So that can be a little bit of a help because you've got 3 different pathways you can take, but it's also a little bit of a hindrance because you might end up going down the wrong path at some stage. So just take care with that.